Thank you all. My name is Gerben, and I'm very excited to speak to you today about my favorite topic, monorepos. I'm from Dexter. We are doing machine learning to try to make the world a better place in the energy sector. And today I will tell you about how we introduced a monorepo, and we'll give you some very concrete ideas and feedback on how you could do something similar in your organization. As you probably know, working on shared code can be pretty hard. Suppose you have, for example, the situation where you have two teams, one working in one repository, one in another repository, and they are sharing a piece of code. This piece of code is a shared package, maybe on the internal PyPI or whatever your local setup is. But it's living in a separate repo, right? Suppose you're working in team A. You are a developer, so there she is. And she wants to make a little change in the shared package that we have here. Well, all good, let's go there, let's move to the package, check out the repo, and let's try to make our change. Well, too bad, this package has not been touched in a while, so CI is broken. So first we have to fix that. After that we see, oh, wait, the dependencies of this package are also outdated. So we also have to fix that. Our developer got the sneaky suspicion that maybe those new updated dependencies are not really in line with what they currently are running in the repository of team A. To check that, she makes a release, grabs some coffee because you have to wait for CI, moves back to repository A, and indeed there was an issue with the dependencies. So she fixes it there, and then after that, she goes back again to the previous repo, and does the actual code change. Make a new release, grab some coffee, move back to team A, and well, the unavoidable happened. There was a bug. So what does she do? She goes back, again, make a release, fix the bug, grab some coffee, and now finally we have a successful minor change. And we have had a lot of coffee. Being the good citizen she is, she also moves to team B, and she says, hey guys, aren't you also using the same package? Do you want me to have a look at your code and check whether you could also use that? Well, here there's a dependency issue as well. And then unfortunately, she is not very familiar with this code. The team is overburdened. They're a bit busy. So they say, well, we will fix this later. And as a result, we now end up with two versions of shared package X in production, one on the old version, one on the second version. So to summarize the pain points we have seen in this very little example, it's very easy if you have a setup like this that you run into outdated CI, that you run into dependencies that you have to fix across. There's a lot of waiting on CI, there's a lot of context switching, there are external dependencies to coordinate, there are internal package versions that you end up with, and then you have to coordinate all those code changes across teams, which can become very, very painful. So to summarize, there's a lot of friction in this setup. Friction, of course, is not nice for us as developers, but it also has business consequences, right? Because this friction will definitely make our nice developer reconsider next time whether she really wants to touch this shared package. Maybe it's easier to just work around it because she remembers all the coffee she needed to have, all the waiting, all the context switching, all the annoyance. So as a result, there's less collaboration in your code base. As a result of that, there's a lower speed of development, and as a result of that, your time to market is longer, right? So this really hurts the company in the end. Luckily, there's an answer to all of this. The monorepo. There's a lot of large companies using this, Google, Uber, Meta, etc. Adyen is also using it. Thanks for the great talk, by the way, just before me. It was really nice. Last year, there was a good talk by Adyen, actually, on the monorepo, so I encourage you to watch that. But what is a monorepo then, actually, just to get everybody on the same page? This is the situation we had before, right? So what would that look like in a monorepo? Well, there you would have only one repository that now houses the code for two teams and also the shared package. So, yeah, a very different setup. You would still have like independent releases, right? So it's not the case that you now have to release all your code at once. Everybody can still do their own thing. But the code is living in one repository instead of two. So how does that then solve the problems that we just had? Well, if you look at the first three, then you would make your life a lot easier if you only have one CI pipeline and one set of dependencies. Then you don't have all this coordination that you need to do. The managing of internal package version basically also disappears because there are no internal package versions. Everybody is just on main, which really helps. And coordinating the code changes across teams becomes way easier as well because you're on the same repo and all the meetings you were having become just merge requests and some discussion on Slack, and that's all you need. So a lot of the friction disappears in this magic world of the Monorepo. That's it. I'm hearing you think, right? Like, but what about, how do I even start this? And don't I need like a big build system or some complex stuff to make this happen? Is there a lot of engineering cost up front? What are the consequences of my choices? How do I get my whole company on board in this new magical thing? And how do I prevent, and if I have everything in the same repo, how do I prevent that everything becomes dependent on everything and I can't move anything anymore? Well, those were exactly the kind of questions that we had when we started to look into this as Dexter. So in this talk, I will talk you through how we went through this experience, and hopefully you can learn from the learnings that we have had along the way. Hence, the gentle Monorepo. We're not doing a upfront, big, engineering-heavy thing. We're just growing it organically from a small seed to a little plant, and we see how it goes along the way. So let me first give you a little bit of business context so you know what we are talking about. At Dexter, we are very passionate about the future of renewable energy, and we are trying to use ML to help renewable energy companies make the best out of their assets. So we have different products that do that. One of them is forecasting. That's maybe the most obvious one, right? It really helps if you have a wind turbine, if you know how much wind or how much power it's going to produce. We also help those companies to get their power onto the right energy market. There are different markets to choose from, and you can play around with that a little bit. So we help them with trading. Maybe surprisingly, sometimes it pays off to actually shut down your wind turbine and not run it on full speed. So we can also help with that, like deciding when you want to do that. And then the last thing, something that we are looking into right now, is developing products for batteries, which are, of course, also going to be a big part of a future energy system. All those 4 products are powered by machine learning and forecasting and similar, let's say, building blocks behind the scenes, right? You can imagine that we have like observability and logging and data sources and feature engineering, all the classical stuff that powers those 4 different products. Some components could be very general, some are very much tied to a specific use case, and everything in between. So what happened in reality is I was working in the intraday trading team, my neighboring team was working on turbine shutdown logic, and we were both at the same time working on building up a better way of doing feature engineering. So that's where the idea got born that, hey, maybe we can do this together, maybe we can do that in one monorepo. So that's the use case I will be focusing on here. Those 2 teams that are really wanting to build one common piece of code. When we started looking into this, I found the first thing we found are those larger, relatively complex, monorepo-focused build systems like PANS or a Bazel. Or they're more. They looked to be nice, but maybe too complex for a use case. They looked very heavy-handed, a lot of configuration, need quite some upfront investment, so that was not really a good fit for us. So instead, we found 2 tools that together basically solved most of our problems. The one was pretty new when we started, but is like household name now, UV, right? I don't think that I have been in one talk that hasn't mentioned UV yet on this conference, so it's old news by now. But UV really helps because it just makes dependency management in a repo that's probably larger than your typical repo super easy. So without UV, I'm not sure we would have been able to do this. Then the second one is way less well known. This one is called Polylith. Maybe raise of hands, who has heard of Polylith? Yeah, the Dexter guys, they don't count, and apart from that, only a few. So that's so I'm bringing something new. That's great. Polylith has been developed by a guy called Joachim ten Stran, who was working in the Clojure programming language. And then there has been one other guy, David Vujic, who basically ported the Polylith tooling and architecture and thinking from Clojure to Python. And I'm very indebted to him because he basically did all of the hard work, and now I can just stand here and present how he helped us. There are a few very key concepts in the Polylith world that you need to understand. Let me first say Polylith is basically more like an architecture, a way of thinking on how to organize your repo with a little bit of tooling on top than anything else. So it's not like millions of lines of code. So it's a very simple, it's more like it helps you to think about how can you structure your thing and have some tooling around making it happen. So let me introduce to the main concepts that we have in Polylith. First one is bases. What is a base? A base is basically the entry point of your code. So it's typically a REST API, or it's a CLI, or maybe it's a notebook that your data scientist uses on a regular basis to do something. And then the analogy that we like to use is they're a bit like base plates in Legos for the people that build Legos. Second concept, components. Components are like the pieces of code that you really, really care about. So this is where your features are, or your business logic, or the things that really, really are important, that contain the core of what you have. Components are like building blocks in Legos, right? Third concept, projects. Projects are basically where you tie everything together. So a project is your definition of the deployable artifact, so the thing that you actually put into production. So that's basically like a combination of your bases, your components. The gray blocks are like external libraries, like so pandas, requests, or whatever. And then the manual, like the Docker file or the DAG definition or whatever you have in place to make this into a thing that actually runs, right? And then maybe the last concept is the development project, which is your playground, which is where you have access to all your bases, all your components, all your external dependencies in a harmonized way, and that's where you start prototyping your stuff, and that's where all your great ideas are born. So in our case, we have called our Monorepo Flint for historical reasons. I won't go into that for now. And basically, the structure looks like this. So you can see that it's all the things that I just explained just come back here directly in the directory structure. So you see your bases, components, the development folder, projects, and then some workspace.toml is some configuration file, not super important, and your standard PyProject.toml and a uv.log, which should be standard by now for most of your Python projects, right? In PyProject.toml, things look very much like you are used to. There's a few smaller differences. Well, the project block is basically the same as before. The build system, there you need a little bit of config to make this work. Dependencies will just contain all your dependencies. And then the special thing is the table called tool.polylith bricks, where you basically list all the bases and components, which we together call bricks. Those you list here. And then this is what the Polylith build hook, which is what it basically is, uses to make sure that the whole thing works together. A little bit more detail, if we go back to the directory structure here, if we extend that, you will see, so you see how this then looks like in the repo or locally on your computer. You see that indeed within the bases, we have those two bases, we have here one component, and you see the project definitions, right? So they live in the separate folder under projects. So a component in Polylith, and this is a very important difference between a component and a, let's say, a full-fledged Python library. A very important thing to understand is that the PyProject.toml definitions, they do not live in the components. A component is more lightweight than that. It's really just a dunder init file and your code. So in this example, the feature engineering component contains datasource.py. There we have a class for the data source. And then in the dunder init.py, that's also there, we basically, that one basically serves as an interface. So here we just list everything that is supposed to be accessible from the outside when you're using this component. And then the Polylith machinery behind the scenes makes sure that you can write your imports very nicely, like I show here on the slide. So you see from Flint, the name of your monorepo, dot the name of your component, import the thing you want to import. So the component subfolder subdirectory basically disappears, and that has to do with the way that Polylith is building the package behind the scenes. So that's all there is to a component. So you can imagine that making a component, which then can be shared by different products, is super lightweight, which is one of the key advantages of this approach. But then you might ask, okay, how do you do then manage your dependencies, right? Well, it works like this. Everything that you will ever need is in the root by project YAML file, as I already told you. And you will make this just a normal way. So if you want to add something, you just use UV add as you would do normally. And then UV behind the scenes will create a log file for you that logs it down to a specific version of your dependency. Important point here is that the whole repo shares one set of dependencies, which is amazing, because that means that when you move to another piece of the code, you don't need to switch your virtual environment, your IDE doesn't get confused, and you're guaranteed basically that anything that's in the Monorepo you can play with. It's all on the same set of dependencies, so it really makes it very quick to try out something that another team has built and see whether it would fit your use case. So how does this then boil down to the different projects? So a project, again, is the thing that you want to deploy, right? So there we also have by project YAML files, which basically define a subset of the total set. So think about it as a way of filtering down, okay, for this specific thing, I don't need PyTorch. I only need a very small subset of everything. And you don't, this is a key point, you don't need to specify any version numbers here, because that's taken care of on root level. So here you just define it on, you just list the things you want, and then you move from there. The polylith tooling helps you to make this consistent in the sense that if you import here the green block and that actually needs pandas, it will remind you if you haven't also listed pandas as a dependency here. So that's where a little bit of the tooling helps you. And then you use CI to basically hook up everything here and make that work together. Give me 1 minute to make it a little bit more concrete. So how do you do that then in practice? Well, the way we do it is we build a wheel from the project file, right? So then the wheel is smaller than the full Flint repo. It's only the things that you select in that specific project file. From the log file, you create a constraints.txt using UV export, which is existing functionality. And then when you actually install the package in your Docker file, you use the -c command of UV pip to constrain the dependencies to really match with the versions that you're having here. If this went beyond your head, don't worry, this is the most technical I will become. So you're basically now ready to start. So the only thing you need to do is you find your own team, your neighboring team, and you start maybe harmonizing your repos already before that. So I'm thinking like linting rules, dependency sets, etc., etc. You clone the polylith UV example repo that David made for us. You build a CI pipeline following the recipe that I had on the previous slide. And then basically you're ready to move your code in. You just make what I would call a fat base, so you're not doing like the entry point thingy, but just copy your whole code base of team A into one base, the whole code base of team B into the other base. You check if everything works, and after that the fun begins. Now you can start taking out your specific shared code into one component, and you can start working together. That's all there is to starting a Monorepo. You don't need anything more complex than this. So how does this work out for us in the early phase? I will share 3 learnings for you on what we did there. Most important thing, of course, is to work together, right? Like, you have to get used to working together on this component. All of a sudden, you have 2 teams. You need to compromise. You need to figure out how you actually work together. You need to figure it out. So there's very much a social component to this, right? It's really not about the tooling. It's more about how do you design software together. That's a very important part to really pay attention to. A second point that I also want to mention, for us as engineers, it's easy to get lost into all the what-ifs, right? What if I get conflicting dependencies? What if this one team really needs to stick on fast API 1 and I want to move to number 2? What if our test set gets too slow? Please only solve the problems that you actually have. Don't assume that you will have a problem in the future. Solve it now, so you get stuck into all these what-if scenarios and you never get moving. Only solve the problems that you actually have. There is a fantastic article around this called The Best Simple System for Now, or Bison, by Dan North. There's a link on the slide. I recommend you all, for bedtime reading, read that thing and read it again in 3 months. and then after 3 months again, because you will have forgotten it. Third point, when you make decisions, so when there's a concrete problem and you're doing some design, write down the outcome of your decision and your thought process. So next time you come across the same thing, you can look back at what you decided, why you decided it, and whether you should change your mind, or whether you just forgot the main argument that was there in the first place why you made this decision. What we use is a tool called ADR, which stands for Architectural Decision Record, which basically is just like a markdown template that helps you to structure your thoughts, write down what you actually had decided, and then what you do is you just commit this to your repo. Don't put it on Notion, don't put it in Slack, put it together with your code so you make it possible for yourself, for your future self, to actually find it again. Because you all know if you have a repo here and a Notion there, you will never find it again. Okay, so we were well on our way. We had our 2 teams very happy collaborating. And people started to notice, right? So other product teams also started to hear about this Monorepo thing we had going on, and we also wanted to grow it. So how do you go about the growing phase? How do you grow from 2 teams to multiple teams? Well, the first thing is, of course, you have to convince people. And in this case, it was not so hard. It was really just about sharing what we had in some company talks, be at the coffee machine at the right moments in time, talk to the right people, and then, especially when there were new initiatives starting, make sure that you talk to those guys that are about to make the wrong choice and start their own repo, and try to convince them, looking at you, try to convince them to join the Monorepo effort. And that went pretty well. I think now I have only 1 convert left to make, and after that, all the product teams in Dexter are in the Monorepo. Second very important thing is when you start to grow, you really need to start building a community. Because when you grow to more people, you can't answer, like the founders, if I can call it that, can't answer all the questions anymore, right? So what we did is we made a Slack channel. Our Monorepo is called Flint, so our Slack channel is called Flintstones. So we were really making sure that everybody that started the Monorepo got very active there. So response time to questions was very, very low. We were very quick. Really invested some time in making that happen. And I think we succeeded. So Flintstones channel is very active still now, and you see that people are starting to contribute and feel safe and can answer can ask their questions, etc., etc. So that seems to be working out very well. And then the third point, which is a very tricky point, is when you get more people, you also have to have some way of fighting the chaos, right? Because you will have people with some different assumptions. People might do things that you don't really like or understand. You have to somehow make some rules. On the other hand, you also want to make it friendly and keep it friendly, right? You also want people to contribute and not get back into this trap where they say, well, it's so difficult to contribute to the common thing, I will just build my own thing in the corner, because that's easier, because then we're defeating the purpose. One thing we do use to enforce some rules is we use a tool called tag. I will just demonstrate how it works. I think that's quicker than trying to explain it. What you have at tag is you have a file in your repo called tag.toml, and there you basically define which modules import from which other modules. So here you see the logging module does not depend on anybody else. The market data platform module depends on 3 different things in this case. Then tag is a CLI tool that has tag check, for example, as a command. In this case, it would go green. But if I now would comment out the data pipeline base thingy, and then I would run tag check, then you will see that it complains, and it will tell you exactly, hey, you're making this import, but that import is not in the list in tag.toml. And then you have a choice, right? You can say, okay, well, I actually want it, and then you add it to the list. Or you say, maybe I'm not so sure that I really want to import scikit-learn in my logging module, and then everybody is stuck with scikit-learn in all their little projects, right? So this really helps to make a conscious decision around your imports. And it also helps you to be maybe a little bit firm on this when you do merge requests. Because we run tag check in CI, of course. So we have the guarantee that if you have a merge request that actually adds an import, then it will be reflected in tag toml, so there will be a git diff on the tag toml, so it's very easy to spot for a reviewer. So that works actually pretty well. There's only one problem: this tool is no longer maintained. The good news is I am talking to the Polylith tooling guy, to David, and we are discussing whether the Polylith tooling could take this use case as well, and because it shouldn't be too hard, so maybe I will have some good news on that next year. So where do we stand right now? Well, when we go back to the what about questions that we had at the very beginning, I already answered how to start. UV and Polylith is basically all you need. Do you need a build system? No, you don't need a build system. In the growing phase, we discovered that as long as you keep things small, simple, then you don't need any dedicated engineers, at least up front. You can do quite a bit with just the engineers that you already have in the teams. When you try to think about the consequences of all your choices, don't. Build the best system for now, nothing else. But if you make a choice, document it in your ADRs, so you have a very good basis to build upon, even if the founders would leave the company or whatever. You have everything documented, and you can just build upon that. In the growing phase, how did we get everybody on board? Step by step. We're still working on it. Leon, where are you? I'm coming for you. And how to prevent a big ball of mud where everything is dependent on everything? Well, there you can use tooling like tag and some other things you could do. So that's what we did. But did we actually succeed in terms of the business goals that we tried to accomplish? It's of course very hard to measure because we don't have a counterfactual. But I think it's fair to say that for some of the things we did, especially the battery optimization product, the tech lead of that team has said that they saved months of development time by being able to reuse a lot of the components that were so easily available in the Monorepo. So, and that's amazing, right? Because that's exactly what we were aiming for. Secondly, I can really say that our shared code is really well maintained. I'm seeing refactors and improvements and changes on code that I'm very sure would be way more stale and harder to change if it would be living in a separate repo, because that's the alternative pattern, right? So I'm very happy with that. That's really nice to see. Third point, I see a lot of reuse. I see that more and more products in the Monorepo are reusing more and more of the common components. We have had a case where a large piece of tech debt disappeared disappeared, it was a lot of work, but a legacy product decided, okay, those classes and this way of thinking that we have in Flint is designed for reuse, it's more stable, it's more modern, it's better, because more people looked at it, right? So they saw that as a very good way of getting rid of their tech debt. So they moved into Flint, which was like step one. And then after that, they slowly started to reuse those common components that we built there. And then the fifth thing that I want to mention is that I see that engineers that are in different teams that were not talking together about code design and things like that are now talking together because they are in the same repo. So we basically moved a lot of the technical discussions down from product manager engineering level. We moved it down into the Slack channel and in MRs, et cetera, which I think is not a very tangible, I can't put numbers on that, but I feel that that really benefits the quality and the quality of what we're building. Well, is everything unicorns and rainbows? No, it's not. There's also some challenges that we are facing right now. We see that the larger the repo becomes, the more challenging it becomes, of course, to keep the overview. Answering a question like, I want to have this functionality, does it already exist somewhere in the Monorepo or not? And if it exists, does it really fit my use case, or should I try to generalize it or change it a little bit to fit my use case? Well, that's not always an easy question to answer. Another point that I want to mention is ownership, governance. How do you make sure that you keep a core of people that really contribute to the common components? Also allow for some free riders, right? Some people that just use what is there. Not everybody has to contribute all the time. But how do you organize yourself in such a way that the thing keeps alive and doesn't slowly deteriorate over time? That's not a solved challenge, I would say. Yeah, I think those are the most important things I want to mention here. So to come back to the tagline of my talk, I think that we succeeded in making something where we ship faster than we did before, and where we collaborate better. A Monorepo is nothing to be scared about. You only need those 2 tools. One of them you're probably already using. So just check out Polylith, get started, take my slides, have a look, and go building. Thanks.
Thank you. So we have a few minutes for some questions. Yeah, we'll start here.
Great talk. I'm a bit of a skeptic when it comes to monorepos. This looks great because it's all Python, but what if you have to add a giant React framework and all that stuff? Because you tend to pull in a lot of build system, whereas you're claiming you don't need it. So I was wondering.
Yeah, no, I'm definitely only restricting myself to a single language Python setup. So that was a premise, yes. If you do something else more complicated, I'm out of my depth, and I wouldn't know how to answer that.
Thank you for the talk. Maybe I've lost it in one of the slides, but how do you manage component versions? So team A changes a component with breaking changes for another team. How is that handled in a monorepo?
Yeah, so in a monorepo, for such a component, you don't have versions. So basically, you're trading off 2 things, right? Like, if you have a separate setup, then you can do versioning, and each team can move on their own pace. On a monorepo, you don't allow that, basically. So what you do is, when you are evolving this common component, then you will hit a unit test from another team. They will start complaining, or you will see your CI go red, and then you start a conversation with the engineers in that team. So you're moving, and so the price you're paying is that you're maybe a little bit slower in evolving your packages, right? And the benefit you get is that you will never have multiple versions of the same package running at the same time, because everybody is always on the latest version of the package.
So who fixes the breaking change then?
The Flintstones fix it. But I would say, well, in practice, what happens is that you either start a discussion on Slack, or it's also not uncommon that people say, hey, I made this change, I saw it breaking in your product, so I made those changes for you, can you review this merge request for me? Because don't forget, it's super easy for people to do that, right? Because you have the whole repo checked out on your own computer, so it's not that hard, typically, to understand, hey, what's going wrong, and how can I fix it?
Okay, so it's more of a communication thing and also collaboration.
Exactly, yeah, and you force, in a way, you force more collaboration, which I think is a feature, not a bug, but there maybe opinions can vary.
One more question.
Yeah, we are also using a Monorepo, and therefore your stories, I really liked your story, it sounded very familiar. I'm recognizing a lot of things you mentioned, but one thing I didn't hear you talk about is one thing we start noticing when we are using a Monorepo is that the frequency of commits to your Monorepo is increasing because all the merge requests or pull requests are happening on a single repository. And each of them might trigger a CI/CD pipeline. So we spent quite a bit of time getting more smart about triggering only specific tests in order not to make your CI/CD too expensive. Have you had any solutions for that?
Yeah, definitely. That's also something that that we started to notice. It's one of the things that we already identified at the very start and then decided not to solve. Ref, best simple system for now, right? But then later we made some iterations on that. So right now, Tag, the tool that I mentioned, has a pretty good way of doing selective testing. So on a merge request, only the tests that are actually related to the code that you touched are running. So that's all built in Tag. Polylith also has it built in, by the way, in a slightly different way. What we're doing still for now is every merge to main runs the whole test suite, which is our next pain point right now. So right now we are looking into parallelizing the tests a little bit more per product and figuring out how we can do that smarter. So I recognize the pain. I think we are working towards solutions, but it's definitely one of the things that is not 100% optimal yet.
Amazing. Thank you so much for this great presentation. Last round of applause, please.
Thank you.